Okay, another example still about resistive force problems. So here, a particle of weight, so now they are giving us weight. You have to be always careful when you hear the word weight, because there is a difference in the way of how we handle when they give us weight and when they give us mass. So it's resting in contact and in contact with the rough plane inclined at an angle alpha to the horizontal, where tan alpha is that. Tan alpha is this, which you can every see. We have this is going to be the opposite of adjacent because of tan, and you can aggregate this using Pythagoras theorem, and that one is going to give you a 5. The coefficient of friction between the particle and the plane is mu, and the horizontal force P is applied to the particle. Full stop. When P is equal to 16 newtons, the particle is on the point of sliding up. So here, when P is 16 newtons, the particle is on the point of sliding up. When the particle is on the point of sliding up, find mu. Now here, first of all, we have this reverse put. This is going to be our weight. Our weight here is 8 newtons. Why? Because they are giving us weight. We don't need to multiply with the give. We only multiply with the if they give us mass. So resolving this, of course, it's going to be having a resultant acting on it. And then like this, then we are going to be having, this is going to be our alpha. Then this will be 8, then cos alpha, and then this side downwards. We are going to be having 8 sine alpha, resolving this weight. And now there's a force which we are going to apply. This force they apply on this body, horizontal, so horizontal force. So they are applying the horizontal force onto that particle. And now they are telling us that first here it is 16 newtons. Now, whenever you have that force, we resolve it. So we resolve it like this. And then we shall go. Remember, or is this angle the same as that angle? Because this is on. So that this is going to be equal to that. So we shall go downwards, then we shall go this side. So because this is opposite, this will be now 16, because it's opposite sine alpha, and then this one will be 16 because it's adjacent. So adjacent goes with the cos alpha. Now, because it's sliding up, it's about sliding up when you apply this. It means that now this is our frictional force is going to be in that direction because the body is sliding up. After doing that, the rest are very easy. So they are telling us to find mu. Find mu, if we are resolved perpendicular of the plane, we have R. If we have R, then we have those which are going, which are opposing, which are to be equal to 2. Because up along the, perpendicular to the plane, there's not any motion, meaning the forces are balancing. So this force which is going up is going to be balancing with this, and then this sort to be equal to 16 sine alpha plus 8 cos alpha. And from there you can get them. So it's that our sine alpha from here is going to be opposite over hypotenuse. Then our cos alpha is going to be 4 over 5, adjacent over hypotenuse. So putting them there, our R will be 16 into 3 over 5, then plus 8 into, this is going to be 4 over 5. And from there, our R is going to be, this is 48 plus 32, that will be 8 divided by 5, that will be 16 newtons. So we have our R. After adding R, then we need to put into, we know that frictional force is having the mu we are looking for. So now we resolve, remember it's about to move up, so the acceleration is going to be, it's most likely to be in that direction. So if you resolve along the plane in that direction of the acceleration, so now in that direction, what is pulling it up in that direction? We have first of all 16 cos alpha, but you know the particle is about, so meaning this at rest, we don't have any acceleration. So meaning these forces which are pulling it up and those which are pulling it down are balancing. So meaning the 16 which is pulling it up is going to be balancing with this one which is pulling it first the F, then plus the 8 sine alpha. They are balancing. Those pulling it up and those pulling it down, they are balancing. That's why it's about to still at rest. So putting these ones here and take it this side, we have 16 into 4/5, then minus 8 into sine 3/5. And remember our friction force, F. So this one is going to give us, when we simplify this, we are going to have then minus 32. So there we are going to be having 32. We have 32 over 5 equaling 2. Now remember this one is mu r, which will be our mu into our r. Sorry, when you simplify at once, this is going to be then minus this. This 5 is not that because it's cancelling out. So what's that stuff? Sorry, that stuff. So if I'm to rectify this, maybe, so we are going to be having this times this, we are going to be having 64. Remember, I have the same LCM 5. This times this, we have 24 down over 5. So our R from here is 16. So now that when we subtract here and divide by this, we get 8 equaling to 16 mu. And so from there, our mu is going to be 0.5. As simple as that. So that's how you get our mu from there. So now, when it comes to part B, P, we now find P, so that the particle is just prevented from slipping down. Now this particle is slipping down. So what do we do? Start by putting also our R. Then we are going to have our weight, which is still 8 newtons. If we resolve this weight, we are going to be having 8 cos alpha. And then along, this will be giving us 8 sine alpha. Then after that, we need now this force P. Now we don't know this force P. But this force we need is just preventing it from sliding down, meaning if it's going down, it means that our frictional force for it is going to be opposite. Because this is sliding down, slipping down, so meaning that our frictional force is going to act in the opposite direction. So now whenever we have this force, we resolve it so that into a component which is perpendicular to the plane and a component which is parallel to the plane. So remember, it's horizontal, so this is going to be equal to that. So this will be P, because this is opposite, so we go with sine alpha, and then this will be P, where it's adjacent, go with cos alpha. So now we need to get this P. So that's how the different this question is. This one, because of this one sliding down, it changes. Because this one was sliding up, but this one is slipping down. So meaning the frictional force is going to change. Okay, so from there, if we resolve perpendicular to the plane, we have our R. This R, because we don't have any action perpendicular to the plane, I mean any access to perpendicular to the plane. So it's going to be equal to 2. First of all, this one is going down. We have this and this. So P sine alpha plus now 8 cos alpha. So if we substitute in there, we have P, our sine alpha is 3/5 plus 8, our cos alpha is 4/5. And from there, you can see that our area is very big. If you get LCM, 3P, this will be 32 over 5. I call this equation 1. So after having that, then of course those are newtons. Okay, let me put newtons. Then if you now see our acceleration now is going to be in this direction here. That's where our acceleration is going to be, because the body is slipping down. So now we resolve in this, we dissolve in direction of the acceleration. That is the best. So now what is pulling it down? First of all, we have this force which is 8 sine alpha, but there are those which are opposing. The one which are opposing, we have this one. So these opposing forces will be equal to this. So this and this. So P cos alpha, then plus F. Because the body is about to slip down. So it's not accelerating yet. So meaning if it's not accelerating, forces which are acting downwards are going to be equal to the forces which are acting upwards along the plane. That's why this force is going to be equal to this, then plus this, because the body is at rest, so the forces are in equilibrium. So this will be giving us 8 into now sine alpha. Sine alpha correct here is 3 over 5 equal to P cos alpha over 5, then plus F, which is mu R. But Rf is mu R. What is our R? We have our R here and we have our mu M. Let me not skip the step and I answer that. Is mu R. Okay, so this one I'll be having that this is going to bring me 24 over 5. 24 over 5 equal to 4p, the whole over 5, then plus our mu, rate is not going to change. Mu doesn't change, so it's going to be 0.5 into now my R. My R is here, 3p, then plus 32, the whole over 5. So if I multiply through by 5, LCM is going to be 5. So I multiply through by 5, so here, this is 5. So if you multiply through by 5, I'm going to be having 24 equal to 4p, then plus 0.5 into 3p plus 332. So if we simplify now, here we are having 24 equal to 4p. Then when I simplify this out, I have 1.5p, then plus 16 with open brackets, which I bring this side. I'll be adding, this will give me 8 equal to 2. When we add it here, we shall get 5.5p. And so my p from there, we get 8 divided by 5.5, and the answer we get is 1.45 for decimal places. 4, 5. So it seems it's the carrying decimal, which we can, okay. If you don't want it because it's regarding and newtons for decimal places. So that's how we handle that question. So some questions you are going to handle them in 2 ways. So when they say slipping up, you note that question is going to be downwards. Sliding down, question is going to be acting upwards. So that's how you handle that question. I wish you well. Or if you want, you can give your P as you divide the multiply by 10, so it will be 80 over 55, which you divide by 5, you get 16 over 11 newtons. So that's the other way you can give your answer. That's the numbers. I wish you well.